Good afternoon, Mayfield. It is Thursday, goodness, January 16th, and this is our first homework video for the year 2025. Our homework, I did ask you to change the date. It was initially all ready to go to be due January 10th, and then we had those wonderful 3 snow days, and so we agreed that, hey, instead of having to recopy the homework, which is not a good use of our resources, we would just change the date to the 17th. So this is our homework that's due tomorrow, January 17th, and we are looking at the beginning of Unit 3 and linear relationships, some proportional, some not proportional. So we can see the first problem says proportional relationships. Second problem says proportional relationships. The third problem, I noticed that if I were to connect those points, I do not end up at the origin, which is a dead giveaway that this is not a proportional relationship. And this was the one that we had the most questions about in the shoebox. So this is the one that we'll do together. We talked the other day about stacking cups. We had a cup and then it was stacked. This says a shorter style of cup is being stacked. So now the cup size is different. So the data is going to be a little different. This graph displays the height of the stack in centimeters for different numbers of cups. So we see that when we have 3 cups, the height is 5.5 centimeters. When we have 8 cups, the height is 8 centimeters. How much does each cup after the first add to the height of the stack? Explain how you know. I want to know what is this rate of change after my initial cup. So what are we looking for? The slope. So I might say first, I need to find the slope. Okay, how can we find the slope? Well, we have 2 options, right? We could go ahead and write the vertical and horizontal distance on our slope triangle. That's always a great strategy. We also talked today about, hey, if I have 2 sets of points, I can also find their slope by subtracting our y values and our x values. So I said, well, one of the things that I like to do to kind of keep myself organized, because it's really easy to flip-flop our numbers and then, of course, get the wrong slope, is I like to write my coordinates underneath each other, and then right away I like to circle my y values to remind myself that's what's going to go in my numerator. So I'm going to subtract 8 minus 5.5 for the difference in my y values, and I get 2.5. So that's the leg of that triangle. And then I have the difference of my x values, 8 minus 3. 8 minus 3 is 5. So my horizontal distance is 5. If you leave your answer this way, I don't think you're going to get full credit, because you're really not telling me how much does each cup after the first add to the stack. So I'm going to go ahead and do a little work to make this slope make more sense. If I have a fraction with a decimal in it, I want to get rid of that decimal. I'm going to multiply both of these values by 10. That gets rid of my decimal. Now maybe you see a relationship already, great, but if not, I always like to show out a good strategy when I can. 25 and 50, well, I can divide both of those by 5 and get 5 over 10. And I could simplify again and divide by 5 and get, 1/2. Okay, so what does that mean if I'm looking at my y over my x? Y is my centimeters. 2 is my x value, which is my cup. So it means 1 centimeter for every 2 cups, or that would mean each cup adds 1/2 centimeter to the height. And of course, all of this beautiful work helps support my answer. All right, I hope that helps. I will say for this one here at the bottom, we have some data, and then we have some more data, so you might want to take your 4 and your 5 and maybe put it up here. Sorry about that. I wish that was a little bit better when I copied it. That was my mistake. All right, I hope that helps. I'll see you tomorrow. Remember, we have lesson 8 tomorrow, and then next week, review, and then our quiz on mid-unit 8, linear relationships. See you later. Bye.